Hey guys, it's Wilson, and I want to show you guys today how to make an objective decision about which tessellation or any design that you are going to decide on. So, most of the time, when we as humans go about designing something, the first design we make is our favorite. We fall in love with it. We decide that that is the best design, but it's not. We know that our best design usually, or our first design usually sucks. So we design other ones. We make 2, 3, or 4 other designs, maybe 10 or 15 if we're working in a group, and then we have to decide which one's the best. This one, number 5, is the best. Why? Why are you choosing one to be the best? This is the question that's going to get asked by the person who's spending money helping you design and fabricate the product. If you come up with a bunch of different ideas and you say, my design's the best one, we should spend $1 million prototyping and developing it, they're going to want to know why. It needs to be objective, not your opinion. You need data and facts. And here's how you get them. This is Excel. Excel is a spreadsheet. This is a tool that we can use to organize numbers, and it's a tool that we can use to make math happen. It'll do math for us. So I'm going to say this cell is going to equal the sum of these 3 cells, 7. Well, we know that. Here's what's cool. If I put a 3 in there, that turns into 10. If I put a 10 in here, that becomes 16. Excel will do math for us on the fly. Let's make that useful for us. What I've done here, I want you guys to copy down. Yours can look a little different than mine, but you need to have a multiplier. You need to have all your designs. You can name them whatever you want. This is Fred's design. This is Sarah's design. This is John's. And this is Barley, my dog. Show John some respect. Show Sarah some respect. Okay, apparently I only respected my dog. There we go. All those are capitalized. So here's everybody's designs. And up here, these are our criteria and constraints. We're trying to prove which design is the most successful at solving the problem. So we're going to use the list of things the product has to do or be to be successful. Our criteria. My group wants to win. We're trying really hard to design a tessellation that's going to be the most successful so that everybody votes on it. So we added attractive. We added not just that it can be built, we want this to be easier to build than the other ones. Because that's important, because you guys saw it in the hallway, we need to make a lot of them. All right, here's what we're going to do. First thing we're going to do is we're going to figure out which one is the most important, second most important, and so on, and we're going to rate them. So I think the most important is that it fits in a 7 3/4 inch box. 1, 2, 3, 4, 5, 6. High score wins. We give them a 6. So we're going to score everything. We're going to score Barley's design on how easy to build it is, how it represents computer science, and so forth. And the biggest score wins, and that's what tells us which one is the best. Oh, this is dumb. Move totals over here. You'll see why. All right, this is the most important because if it doesn't fit the wood, it doesn't work. I think attractive is the next most important, represents computer science is the next most important after that. Easy to build is still really important. These are more important. Let's say that, and then this one's the least important. What we're going to do is we're going to multiply the scores that each design gets by the multiplier. So getting a high score and then multiplying it by 6 really, really, really helps you win. All right. Next thing we need to do is choose, I'm going to make these gray. Cool, so they look different. While I'm at it, let's bold those. All right, now it's starting to make sense. What I want you guys to do here is choose a scale. I like 1 to 5. You could choose 1 to 10. Could choose 1 to 3. I like odd numbers because then you have a middle number. You can give it a 3 out of 5, which is right in the middle. But it's up to you guys. Scale. Cool. All right, let's play with this. We're going to score these 4 designs here. Make this like a light green color. And we score them as accurately as I can. Some of these are going to be a little bit opinion. They're going to be a little bit subjective. But if the group works together to come up with these scores, it'll at least be a stronger opinion. So I'm going to say my dog's design, Barley's design, is super easy to build. Fred's is not that easy to build. John's is super hard to build. And Sarah's is almost as easy to build as Barley's. These people don't exist. My dog can't design things on Inventor yet. I'm making up these numbers. I'm making them up so we can get through this quickly. So I'm just going to put in random numbers. I put in 6. 6 is not that much between 1 to 5. So I'll fix that, and 1. All right. So we went through all this time scoring each design on everything that's important for a successful design. Now we need to do some math. This is not important to us, so I'll just black it out. I don't care what the total of my multipliers are. But we need to total Barley's design. I need to create a mathematical formula that's going to total up all of his stuff. So first we need to multiply each of these scores here by these numbers. So I'm going to insert a row by each one. If you grab all the cells at once, or all the columns at once, you can change all their size at the same time. All right. And then I'm going to call this multiplied. Copy, paste, 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 paste. And I'm going to give each of these a different color just so I can kind of pay attention to what I'm doing and not get lost. And good thing I did, because it's showing me that I need another row. Here, make those purple. All right, it's getting a little hard to read here. I can do this. I'm holding Control. It's allowing me to select multiple cells, so I'm selecting all my multiplieds. Right click, format cells, bend the text at a 90-degree angle. And it fits. All right, and that needs to be that color. Cool, this makes sense to me now. Let's make these things multiplied. I'm going to say this cell is equal to this cell. Shift 8 is times, that little star is times this cell, and I'm going to hit enter. Now, this is a cool trick. Watch this. If I type 1 and I have my big fat cross, I can come over here and move that 1 around with the skinny cross with the arrows. But look at this guy. See that thin cross right there? You touch this dot. That expands a selection. So if I do one, or I'm sorry, it expands a pattern. 1, the next pattern is 1, 1, 1, 1, 1. If I grab 1 and 2, go to the skinny cross, it expands it and counts. You can even do crazy things like Monday. Well, it knows then I'm probably setting a schedule. I could go 2, 4, grab those, it'll count by evens, so forth and so on. So I'm going to expand this down and get those numbers. How is 2 times 3 10? How is 1 times 3 2? Something's wrong. When I click on this formula, I can see what it is, and this is B4 times B3. B4 times B3, well, that's not my multiplier. This one's B3 times B2, but when I expanded it down, look at the shape. See how this is an L shape? This one's the L shape moved down. That one's the L shape moved down. That one's the L shape moved down. These expansions didn't work. I'm going to delete them. Watch this. This is really weird, but it works. I'm going to put a $sign right before that 2 because I don't want the 2 to move. Now I expand this down. L shape. Oops. Oh my God. Be careful how you click. B3 times B2. Enter. Okay. L shape. See how this one here is staying up there? That's what that $sign does. Cool. Now these are working. I'm going to grab this up here, copied it, right-click copy. I'm going to paste it. No, I'm not. That's dumb. Control Z. Okay. I'm just going to type it in. Equals this times this. Put the $sign before the 2. That's not a $sign. That's a $sign. I'm very tired. That's a $sign. Expand that down. This one equals this times this. $sign, enter, drag down. This one equals this. You guys can skip this part of the video because it's getting repetitive. All right, stop. This is when you need to pay attention. I'm going to set up the totals, and the totals equal the sum of that shift, nope, this, control, that. It's not working. When you guys get this name, it means your formula doesn't work. So this says sum of nothing. I need to put the parentheses. I click here. I hold control. I click there, 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 and there. Close the parentheses. Notice each column is there. I hit enter, 65. This one I can drag down. Fred, you have made the best design. Why? Because according to our numerical analysis of how successful a design meets its criteria, we have determined Fred's is maybe not the easiest to build, but it's almost the most attractive. I'm sorry, almost the best representation of CS, the most attractive. It does the best job fitting the square. That's a little weird. Doesn't connect very well, but we didn't care much about that. Happens to do a great job with intentional space, but we didn't care much. Okay, guys, if we really don't agree with this, if you really deep down don't think Fred's design is right, we have to fix the matrix. We designed this, didn't we? This is our design. Our design may suck. This tool may not do its job well. Here's where I notice a problem. It either fits or it doesn't. So, and I give Fred a 6. That's funny. Here's what we're going to do. Instead of saying, oh, this does kind of a good job, and this does a worse job, and this does a great job, and this does a super great job, I'm going to just make this yes or no. So I'm going to give these 5s, and I'm going to give these 1s. Actually didn't change the result. I just want you guys to know, you designed this, you can figure out whether or not it's doing a good job. You should look at the answer and go, oh wow, that's a great idea. I do see now how Fred's was the best design. You should agree with this tool. If you don't, look at your numbers and see if something didn't make sense. You can choose something to just a digital, a yes or no, a points or no points. Maybe you go back and say, hey, let's be a little nicer about attractive. And say, well, Barley's isn't that ugly. You can fix it, okay? All right. I want you guys to give this a shot. Remember to double check your Excel formulas. See if you need that little $ sign or not. And good luck.